any idea why reaction kinetics is an important topic? This is actually significant for industry in order to reduce cost. In massive production of any product, the manufacturer must come out with methods in order to increase production of product, increase rate of reaction with minimal and low cost. Assalamualaikum, hi guys. This is the first hour of reaction kinetics. In this video, I will explain to you how to find the rate of reaction of reactant or product and also how to determine the order of a reaction. Now let's look at the first one, differential rate equation. Example 1. This example is given in your module. Consider the reaction N2 plus 3H2, it produced 2 mole of NH3. Suppose that at a particular moment during the reaction, molecule of hydrogen is reacting at the rate of 0.074 molar per second. You have to calculate the formation of ammonia and depletion of nitrogen. So let's look at the information given. So as we can see here, molecule of hydrogen is reacting at rate of 0.074 molar per second. So the information given is dH2 over dt. So dH2 over dt is equals to 0.074 molar per second. So from the information given, you have to find the formation of ammonia. So first, you have to write the differential rate equation. Walaupun soalan tak suruh, kena tulis dululah the differential rate equation. So to write the differential rate equation, first you have to write rate equals to, so reactant always decrease, so kena ada negative, 1 over the stoichiometric coefficient of that certain reaction. So untuk N2 1, so 1 over 1 lah, tak tulis pun tak apa, dN2 over dt, and it is also equals to negative 1 over 3 dH2 over dt equals to positive, because product always increase, so 1 over the stoichiometric coefficient 2 and dNH3 over dt. So the information given for the question is for dH2 over dt, where the value is 0.074 molar per second. So if you want to find the formation of ammonia, so we have to compare the depletion of hydrogen and the formation of ammonia. So negative 1 over 3 dH2 over dt equals to positive 1 over 2 dNH3 over dt. Okay, so untuk peringkat ni kita kena masih salinlah negative sign dengan positive sign ni. And then we are looking for dNH3 over dt. So kita pindahkanlah yang ini ke sebelah sana, 1 over 2 pindahkan to the other side. So dNH3 over dt equals to negative 2 over 3 dH2 over dt. So kita substitute je lah nilai 0.074 ni masuk kat bawah ni. Okay, so masa kita nak substitute tu, kita boleh terus abaikan negative sign sebab dNH3 over dt ni formation, so nilai dia sepatutnya positif. Kita abaikan teruslah negative sign masa kita nak masukkan nilai. So kita akan dapat 0.049 molar per second. That's for question A. Now let's go to Question B, depletion of nitrogen. Depletion ni maksudnya pengurangan. So, nitrogen ni kat sebelah reaktan, so dia akan berkurang lah. So, kita just compare antara nitrogen dengan hydrogen. Ataupun since we have found the formation of ammonia, you can also compare between the depletion of nitrogen and the formation of ammonia. Okay, so it's either one lah. Boleh pilih yang mana-mana. So, negative dN2 over dt equals to negative 1 over 3 dH2 over dt. Okay, since we are looking for dN2 over dt, so kita boleh terus masukkan nilai je lah. Nilai yang diberi daripada soalan. Okay, so sekarang kita just substitute nilai yang diberi daripada soalan. So masa kita nak substitute nilai, please keep in mind you have to ignore the negative sign here. So 1 over 3 times 0.074. So finally awak akan dapatlah 0.025 molar per second. So kat sini sedikit peringatan, negatif atau positif sign ni mesti berada pada rate ni. So untuk N2 it is depletion ataupun pengurangan. So mesti negatif dN2 over dt. So it is different from the ammonia just now. Okay, since ammonia ni formation product, so untuk ammonia kat sini positif lah. Tapi nilai yang kita cari tu akan sentiasa bernilai positif. Yang negatif atau positif hanya berada di sebelah rate. Sama juga yang kat bawah ni. Negatif ni pada rate of depletion of nitrogen. Tapi nilai kat sini, nilai dia mesti positif. So that's for example 1. Now let's go to practice question 1. Consider the reaction 2Hi produce H2 plus I2. Determine the rate of disappearance of Hi. Given in the question is the rate of formation of I2. So the information given here is dI2 over dt. So the value here is equals to 1.8 times 10 to the power negative 6. I will show you how to solve this question. First, you have to write the differential rate equation. So rate equals to negative 1 over 2 dHi over dt equals to positive dH2 over dt equals to positive di2 over dt. Okay, so selalu soalan yang pelajar tanya positif ni wajib tulis ke tak? So better tulislah untuk to show that product always increase and reactant always decrease. So soalan tanya the rate of disappearance of Hi. So given in the question is the rate of formation of I2. So kita kena bandingkan dua ni lah, dua maklumat ni. So negative 1 over 2 dHi over dt is equals to positive di2 over dt. So yang kita nak cari ialah dHi over dt. Okay, negative dHi over dt. So 1/2 ni kita kena pindahkan ke sebelah sana. So bila kita nak substitute nilai, sila abaikan apa-apa tanda negative sign lah kalau ada kat sebelah sini. So we just have to substitute the values given into the 2 over dt. So 2 times 1.8 times 10 to the power negative 6. So this is given in the question. So you will get 3.6 times 10 to the power negative 6 molar per second. So keep in mind the unit for rate is concentration over time. So tak kisahlah time tu dalam unit apa. So kena tengok soalan. So final answer wajib ada unit. So that's for practice question 1. Now we will go to the next part, order of reaction. So there are 3 orders of reaction, 0 order, first order and second order. So, to write the rate law, rate equals to K times concentration of reactant. So 0 order kuasa kosong lah. So kita akan dapat rate equals to K for 0 order. For first order, rate equals to K times concentration of reactant to the power 1. For second order, rate equals to K times concentration of A to the power 2. Okay, so order ni akan jadi kuasa the power of the concentration. So this is the integrated rate equation for 0 order, first order and also second order. So yang ni semua adalah melibatkan calculation problem. So A0 is the initial concentration, A is the concentration after certain time, K is the rate constant and T is the time taken for that reaction to occur. So samalah untuk ketiga-tiga ni. So yang penting kat sini awak kena identify dulu whether the reaction undergo 0 first ataupun second order sebelum awak gunakan equation yang mana satu. The same goes to half-life. So after you have identified whether the reaction is 0, first or second order, so kita pilihlah equation mana yang kita nak guna bergantung kepada order of that reaction. So now let's look how to determine the order of reaction. So there are 4 methods how we can determine the order of reaction. The first one is from the unit of rate constant. Yang ni yang paling senang. Okay, so daripada unit of rate constant, kita boleh terus identify lah nak guna integrated rate equation yang mana satu to solve that certain question. The next one is using initial rate method. Yang ni biasanya kita akan diberi set of data. Okay, diberi set of data. So from that set of data, we can determine the order of that reactant sebelum kita tuliskan rate law. So kat sini biasanya tak ada. Untuk yang ni biasanya kita cuma nak tentukan order sahajalah, tak melibatkan integrated rate equation. Okay, lagi dua ni pula melibatkan graf. So selalunya soalan yang ni biasanya kena plot graf lah. Plot graf. Daripada graf kita kena tentukan order of that reactant sama ada daripada half-life ataupun from linear integrated graph. So now let's look at example 2. So ni contoh problem solving using integrated equation. So iodine atom combine to form molecular iodine in the gas phase. So this is the equation given. So the rate constant for this reaction is 7 times 10 to the power 9. So the unit is M-1, S-1. So from the unit here, we can see that the reaction is second order. Okay, so sekarang kita dah tahu the second order. So kita akan gunakan integrated rate equation lah untuk selesaikan soalan A dan B. So the initial concentration of iodine atom is 0.086. So ini adalah A0. So calculate the concentration after 2 minutes. Okay, so kat sini masa yang dibagi adalah minit. But the unit for time for rate constant is S-1. So you have to convert into second. Okay, kita convert tu disebabkan oleh nilai disebabkan unit masa sini lah. The unit for time for rate constant is in second. For question B, calculate the half-life of the reaction if the initial concentration of iodine atom is 0.06. So yang ni kita akan gunakan formula half-life untuk second order. For question A, since we have identified this reaction is second order, so kita tulislah the equation for second order. So 1 over A, ataupun kita boleh terus replace dengan reactant daripada soalan tu lah. Minus 1 over A0 equals to KT. So untuk soalan A, kita nak cari the concentration of I. So 1 over I minus 1 over the initial concentration is given in the question 0.086 equals to KT. So the value of K, which is the rate constant, is 7 times 10 to the power 9. Okay, unit boleh tulis, tak tulis pun tak apa. So the time taken is 2 minutes. So you have to convert into seconds. So times 60, so you will get 120 second. So unit tak tulis pun tak apa dalam pengilaan. So finally, lepas awak tekan calculator, awak akan dapat nilai I lah. So 1.19 times 10 to the power negative 12 molar. Okay, final answer wajib ada unit. The unit for concentration is always molar. So that's for question A. So now we go to question B. So we will use the formula half-life for second order. T half equals to K A naught. So 1 over the rate constant is the same, times 10 to the power 9. And the concentration of, the initial concentration of I is 0.06. Okay, for the question B. So you will get 2.38 times 10 to the power negative 9 second. Now let's go to example 3. The above reaction is first order with respect to iodide ions and with respect to thiosulfate ions. So diberi the order is first order and first order for both reactants. So write the rate law for the reaction. So rate equals to K, concentration of S2O8 2 negative, time to the power 1, which is the order of reaction, times I minus to the power 1, which is also the order of reaction. So derive the unit for rate constant. So kita guna balik rate law tadi. Rate equals to K, concentration of S2O8 2 negative times I minus. So kita letak je K sebagai subjek utama, letak rate dekat atas ni. So the unit for rate is MS negative 1. The unit for concentration is molar. So this one is also molar. So kita akan dapat M squared lah kat bawah ni. Kat atas ni rate MS negative 1. So kita akan cancel out. M bahagi dengan M squared jadilah M negative 1. S negative 1 ni kekal. S negative 1.